Types of waves. Real quick review.
Yes.
So a wave, as you might recall from before, is just a disturbance that carries energy through matter or space. And they can make many forms. And we're going to talk about a bunch of them throughout the unit.
Yep.
And if you look at the little diagram down below, it should look extremely familiar.
There's our wave.
If it doesn't, look back to your previous notes because you need to make sure you understand all the parts to that. But that is like the traditional wave we usually think of.
Like the crest and the trough and the wavelength.
And
Frequency,
yep,
amplitude.
hertz.
We already
no
talked
hertz.
about. Yeah.
Sorry.
All right. So anyway, now a quick term, because we're going to be using this for the rest of this little presentation here, is the term medium. Now the medium is the matter through which a wave travels through, if it travels through matter at all.
Well, what type wouldn't travel through?
Well, we'll talk about that in a minute.
I can't wait. This is going to be
Sorry.
exciting.
I'm
Spoiler.
jumping ahead.
Yeah,
jumping ahead.
you're getting
Spoiler
anxious.
alert.
But anyway, so medium is just anything that a wave travels through. So you see there's a picture on your right, I believe, of a slinky that is being manipulated to make a wave. Well, the medium is a slinky, okay? Or if, we've showed many pictures of water waves. The medium for those waves is water.
It's the water.
When you make a wave with your arms, the medium is you.
It's me. I'm a wave medium.
I was going to
So
send
anyway,
a wave to you, man.
That was
That's
cool.
all medium is,
That would be
okay?
coordination.
Now keep in mind, a medium is something made of matter.
Yes.
Yes.
Matter, volume, and mass.
Now the reason this is important is because there are two categories of waves, and it depends on whether or not it's going through a
medium. Yeah, because one type of wave doesn't need a medium
What
to
type
travel.
of wave is that?
That would be the electromagnetic waves. So the one that does need to go through waves, if we look at the top right here, mechanical versus electromagnetic, that is mechanical waves versus electromagnetic waves. Mechanical waves, they need a medium. So water, air, something solid, like us, the sound waves that you're hearing are traveling through the air. That didn't hurt at all.
Yeah, remember
Or
that
hitting
air
the
is
table.
matter.
Air is matter,
That's
and
if-
we all
if
know
you-
that.
You need to kind of wrap your mind around
Yeah,
that one.
air is physical. If you
Pretty-
if you doubt it, turn on a fan and watch your hair blow. That's
So-
air particles hitting you.
Pretty much anything that has atoms in it. you
Yeah,
might
if
say.
it's got atoms, it is a medium that is going to carry a
Okay.
disturbance through it, a wave. Electromagnetic waves don't require medium. Types of radiation or light waves are good examples of this because they travel through space. There is no air in space, yet the light from the sun makes it down to the planet.
So-
the energy from the sun, the heat waves, will travel out from that.
Now, can electromagnetic waves travel through a medium? We just said that it doesn't need the medium, but can it also? If
Some
there's a
can
medium,
pass
can it
through
go?
them, yes,
Certain ones?
absolutely.
Okay,
A lot of
okay.
radiations will definitely pass
Oh,
through that.
like maybe a window?
Or how about
Yes.
visible light travels through a medium? That's why I'm able to see right now.
Ooh,
Yes.
that's true.
See, so visible
But
light can.
there
talk
are
more
some
about
types
that
of
later.
electromagnetic waves that struggle to travel through some mediums, but that's for another day.
Yeah,
So,
we'll go into that more later.
so anyway, now we're talking about two different. So that was one way of categorizing one type
Yep.
of wave versus another. Now we sort of have to switch gears. Here's another way of categorizing one type versus another.
Yeah.
Okay. So there's two different ways you can categorize.
And this one has more, like that, the one we just did has to do with what it travels
What
through.
it travels
this has
through.
more to do with how it's traveling.
Yes.
Yeah, what
exactly.
it's shaped
What it-
like,
yeah,
if
what
you
it
want to
looks
think
like.
about what
Okay,
it
okay.
looks like.
So this first type is called a transverse wave, and this is kind of when we think the way we've been depicting waves. This is kind of
This
how
is
it's
it.
Yep.
Transverse wave goes up and
Up
down.
and down.
Now,
Let's
the
all do
super
it.
sciencey way of saying that is a wave in which the motion of the particles is perpendicular to the motion of the wave as a whole. So, first of all, geometry term. Perpendicular means you have one line going this way.
Okay, and one's going up and
Yeah,
down.
I should probably go not towards the camera.
Like
but I
that,
should go
like
like
that,
this.
and
Okay,
then
yeah.
that.
Yeah, so it's
So the
traveling.
wave goes traveling like
yeah,
this.
It's intersecting, okay?
Yeah, there's that point of rest, that x-axis, and the wave is doot, doot, doot,
Yeah,
like that.
so-
and that's why we get this kind of funky motion up and down that gives us crests and troughs.
Like water waves, they're moving. You're standing on the beach and you're looking at water waves. They're moving towards you. That's the direction the wave is moving. But
Yeah.
the wave is also going up
Up and down. That's why
And
sometimes the waves hit you and knock you
yeah.
down because the top part of the wave, that crest, crashes down on you.
That's what makes it perpendicular. Is the energy goes up and down
Yep.
as it moves towards a point. Okay.
True.
So here's a little quick video I pulled off of YouTube to show how that looks. You'll see this hand kind of looks like a hand.
It's a mummy hand, I think.
You see the transverse wave is going. I'm probably going to point in the opposite direction of the way.
Yeah, it's hard to tell in the video, guys.
The slinky's going up and down while it's also moving in a specific direction.
Yeah.
Okay.
Right.
So you
And
move
that's what
it
makes
up
it
and it
transverse.
travels out.
Now you might be like, okay, so what's the opposite of that? Well, the opposite of that is a longitudinal wave.
And longitudinal waves are pretty cool because instead of going like up and down like a transverse one does, they move parallel to the direction they do. So what happens is like if our wave is going like this,
Yeah.
the wave particles are actually making it shift back and forth like this. Think it's like, and you compress and then you expand, and those are two specific terms called compression.
When you squish it
right?
together,
And then the areas where it expands out is called rarefaction.
Yeah.
It
And here are the
rarefies.
definitions in case you
Right. So the
Yeah.
area in a wave where it's compressed, squished, compression. Where it expands out or spreads apart, that's called rarefaction.
And you might want to also write down your notes. It's labeled on the picture.
Right.
When you measure a wavelength of a longitudinal wave, you measure it either from the point of compression to compression
Yeah.
or from the biggest spread out part, which is the rarefaction, to the next rarefaction. That is one wavelength.
Yep, and usually from the middle of both of those. So that's just the convention at least.
think about this for a second too, guys. What does compression or rarefaction have to do with density? Okay, stop thinking. Let's go on.
All right. Well, should we answer that question, or should we just?
Yeah, let them think about it. They're smarties. They can get
So
this.
All
here's another video very similar to the one before.
Yeah, and this will help visualize that. Here's a longitudinal wave.
You can see the hand pushes forward.
You see no up and down movement.
Right.
Just
No.
in that same exact direction. There's portions where it's compressed, and there's portions where it's
It's
spread out.
compressing something and shoving it
Yeah.
out.
Now it's energy that's causing that compression.
Yes.
Right.
Because the wave is
It's energy, but it's a
like an energy
disturbance
burst,
as a
yeah.
result. Yeah.
And what basically happens is as you push forward, the matter gets squished and then it expands itself back to its original position, and
Yep.
then it just keeps doing that as you keep kind of going through
Yep.
it.
And I think that might be. Oh, yep. So
Interference.
we'll talk about interference on the next video, which you should probably watch about right now because we're actually doing 2 videos in one night. So
Those guys aren't hugging.
see
right?
you over there on that video.
Crashed.
Nah, they just crash into each other. All right.
But
see
they're
you
probably
later.
friends.